All right, so we're going to be working on Unit 1, Lesson 5 notes. This is the review. We're just going to be building our fluency, practicing everything we've done for this whole unit. So the very first thing we said, if f of 3 is 9, so the 3 inside of it just means x equals 9. Then the inverse of the function, inverse of 9 would be 3. So if you see, everything that was x is now y, whatever's y is now x. So same thing is going to happen here. If f of the input equals the output, then the output is going to equal the input. Remember, input is x, output's y. So if you remember our tables from before. So for our next one, if f of a equals b, then the inverse of b, is going to be a. And if f of domain equals the range, then the inverse of the range is the domain. And we actually did that a few times in previous ones. All right, so now here are we going to do these. So this one I would definitely suggest you write on another piece of paper. You get out if you're doing it in class, you're going to be working on your whiteboard, scratch paper, whatever you need to. What you're going to be doing is you're going to find the equation. We're going to switch the equation, find its inverse. Okay. Going to see if I can find some room. Just a minute. I'll have to do it at the top, and then I will erase it as we go through. So for the first one, I'm going to do it in this colors, and I'm going to try to do each one a different color so we can see it matching a little bit easier. So we're going to go x equals 5y minus 7. Remember, we're going to add 7 to both sides. Equals 5y, then divide by 5. And we can see our inverse is going to be x plus 7 over 5. And we can see that right here. There we go. So now the next problem we get, and remember with these problems, you don't have to go in order. You can change around, change out whatever steps you want. So in the next one, we're going to switch it. We're going to get x equals the cubed root of y minus 2. So to get a cubed root, whoops, move the paper a little bit. What we're going to do is we're going to multiply each side. We're actually, instead of taking the square root, we're going to cube each side. That gets rid of those roots, those radicals. So we're going to get x cubed equals y minus 2. We're going to add 2 to both sides, and we can see our inverse. It's going to be x cubed plus 2. So we have this one to this one. It's going straight across. Okay. Not an easy one to brace. Okay, so if we look at the next one, up. Need to get a different color. So we're going to, again, switch our x and y's. So we get x equals 7y minus 5. Remember PEMDAS backwards, so add subtract first. And then we're going to divide. And I think you can easily see what our answer is going to be. X plus 5 over 7. So for this problem, we can see it's right down here. And remember, y inverse is the same as f of x inverse. Same exact thing. Okay. Sometimes erasing is easy on Cami, sometimes it's not. Okay, so we're going to choose pink this time. So this problem, and what we're going to do, again, we're going to switch. So x equals the cubed root of y plus 2. And again, just like the previous problem where we get rid of the cubed root, we're going to do that to both sides. So we get x cubed equals y plus 2. Get the y by itself from minusing 2. So the inverse is x cubed minus 2. And we get that at the very bottom. Okay. Next one, we're going to write x squared. Hopefully by now you guys remember what the cubed root of it is. Okay. So, oops. So we're going to go x equals y squared minus plus 6. We're going to minus the 6 on both sides. So we get x minus 6 equals y squared. And we're going to square root both sides. Usually we're going to do plus minus, but remember, we could also do it as just plus because we are going to restrict it. First, minus 6, and we have that at the very top. I forgot to put the plus and minus, so if you want to put that in. And then the very last one, we can actually see it is which one it should be, but if you wanted to go and solve it, we're going to change it up a little bit. We're going to get x equals y plus 8 squared. We're going to take the square root on both sides. Usually we'd have plus and minus there, but we didn't put it in. And so we get plus and minus square root of, x. I was looking at the next problem. Plus 8 minus the 8. Remember, we can't go square root of x minus 8 because it is a square root, and square roots are very, very picky. We could just do square root of x minus 8. Usually I like to put it in the front, but either way it works. And it's going to match up to this problem. And we get it over here. All right, the next one, we're going to go ahead. We want to finish the problem. So this one we're going to graph it. We'll find the inverse and then graph it, find the domain range, and if it is a function or not, and why. So with this one, remember this is in vertex form. So our vertex, since there's nothing with the x, it's a 0, -2. So that's our first one. So 0, -2. It is opening up because that 4 is a positive number. And to get the next points, we're going to go from our vertex, go up 4 and go 1 to the right, 1 to the left. And we have our parabola. Okay, and then if we do our inverse, love technology at times. Okay, we're going to go x equals 4y squared minus 2. Add 2 to both sides. I'm going to get x plus 2 equals 4y squared. Divide both sides by 4. And I like writing this fractions, but you can always leave it just like this. And 2/4, and I think all of you should remember to simplify, should be 1/2 equals y squared. Take the square root, and remember we are restricting it, so it's just going to be the positive. And I'm just going to leave out the plus minus this time because we're only using one of them. To the inverse. Now the nice thing is, because we are doing the inverse, you could go straight to Desmos and plug in this equation, but we know this point right here is 0, negative 2. So if we flip it, it would be negative 2, 0. And this other one is 1, 2. We're going to do it. Let's see. Oh, sorry. I graphed mine wrong. Let me fix that one. I put it in the wrong side. So it's 0, negative 2. So we need to move this as 0, negative 2, 0. And then this point here is 1, 2. So it's going to be 2, 1. And we can figure it out. It's going to be just like that. Sorry about that. Sometimes teachers write it so fast that we're going to get it a little mixed up. All right. So domain of this one. So domain, if you remember, is x values. So here, if we plug into our equation on the left, the red one or pink one, whatever we plug in, we are going to get whatever x value we plug in, we are going to get an answer for y. So we're going to say this one is all real numbers. And then our range, these are our y values. Okay, the range of the y values. So this one, if we look at the y-axis, it doesn't go below negative 2. And so we can say y is greater than, and you can also make it greater than or equal to. It does. This one's more accurate. I know in the previous ones I took out the little line. Whatever works. Now, is it a function? Yes, because it passes the vertical line test. Okay. Now for our second equation. The nice thing, remember, with inverses is we do switch the domain and range, just like we talked about up at the very top. The domain becomes the range, and the range becomes the domain. But with these, it is a little bit mixed. So our range, we know, is going to come up here. But when we're talking about domain now, it's going to be the x's. So x is greater than or equal to negative 2. And unfortunately, we are not going to say all real numbers for the range for our new equation because we did limit this one. We did limit it. So we're going to go say y, and we can see y doesn't go any, Yes, the y value does not go below the x-axis. So y is going to be greater than or equal to 0 since it does touch. And because we are restricting, we have to write it will be a function, but we have to write we restricted it. Yes, because we restricted the range, so the y values. Okay, we restricted the range. Now with these, what we're going to do is see if we can match our graphs. I'm going to make it a little bit smaller just to make it easier to see, hopefully. So what we're going to do, we won't see all of them. We're going to try to see what would match. And the easiest way to do the matching is to find one point, like this one is 0, 3. In our inverse, we want to find one that is 3, 0. So we want to see, and it's going to stay a straight line. We want to see something that has 3, 0, which doesn't. And interesting of all, these two match, and they're this exact same equation. So strange on that one. Sometimes that happens. So here we see a point that is negative 1, negative 2. Our inverse, we want it to be negative 2, negative 1, and it's going to stay that curved line. Now we can see, let's see, so negative 2, negative 1 right here. This one's going to match. If we go to this one, we can see this point is negative 1, 0. We know it should be 0, negative 1. And if we keep looking, we can see that it is going to meet right here. That's 0, negative 1, right there. Now, the cubes, these are really interesting. So if this one is going this way, the inverse of it is going to be more up and down. So we can see automatically that's the only one that goes up and down. And I'm going to skip down to this one. So this one crosses is going to go up. We know it twists, but if you see it, it's at 0, 2. We know the inverse is going to be 2, comma 0, which is this one. And our parabola, our quadratic, here we have the vertex. This one is at 0, negative 3. We want at 3, negative 3, 0 to be the inverse. And since we restrict it, it is going to be this one. In our next lesson, we're going to be going over a word problem, and then we will be getting ready for the test.